Hello, today we're going to talk about Nomenclature 3. Nomenclature 3 is going to be naming the following functional groups: carboxylic acids, acid anhydrides, esters, acid halides, amides, and nitriles. Also aldehydes and ketones. We have already done alcohols and amines. And in Nomenclature 2, we did aryl compounds and also alkenes and alkynes. So we're going to basically add these on top of the ones that we've already learned. This recording will be about the IUPAC naming. So this entire handout on the front is IUPAC naming. We also talk about radicofunctional or functional class naming. And then on the back, there are some trivial names that you'll need to memorize, and we'll talk a little bit about those just in a second. So coming back up here, hopefully you already know the functional groups and which one's which. There's a little bit of an abbreviation here in the structure column, which shows the general bonding pattern of each of these functional groups. So if you need to, you can obviously refresh yourself on these functional group names and rememorize any of those you don't have memorized at this point. The first thing we need to worry about is the rank. So here listed are the rank numbers. And these are important because when you have a functional or when you have a molecule with more than one functional group in it, you'll need to decide which one is going to be the one that goes in this part of the name, which is the functional group. And what we're going to do is the highest ranked group is going to be the one that gets named as the functional group. So, for example, since carboxylic acids are ranked to number 1, anytime you have a carboxylic acid in a structure, it will be the one that gets ranked as the highest ranked functional group. And that means that it's going to have the ending when it's named as the parent, the suffix, so it will be an oic acid. And if I had any of these other functional groups present listed below it, let's say I also had an amide, and I also had a ketone, and I also had an amine, then these would get moved into the substituents category. So anything that is not the ranked functional group is going to be named as a substituent. So that's why we'll need to memorize both the prefixes that are listed here and the suffixes. So the suffixes are what we use when a functional group is the highest ranked functional group in the molecule. Now, then anything else that exists is going to be named as the substituent. And just a reminder that the substituents get listed alphabetically. Also a reminder that when we number things, we're going to have kind of a priority rank order for how to number the locants, and this also counts for how you find the parent chain. So the first thing that's the most important in terms of locants or numbering the parent chain or finding the parent chain is that we want the functional group, the highest ranked functional group, will get the lowest number possible. Okay, and if we don't have a ranked functional group, which we've studied in the past in Nomenclature 1, then we're just going to worry about the substituent numbering, and we want the first substituent to get the lowest number possible, and then we go to the first point of difference. And then if we don't have any sort of point of difference on that, then we can go with alphabetical by substituent. But that's going to be our lowest priority order, where the first, the one that comes first alphabetically. If we're going to get the same set of numbers no matter which way we number it, but numbering it one way gets the, say, chloro, a lower number than a fluoro, then that's what we're going to do. Then we'll have our parent chain. Then we'll have our unsaturation. So remember, if we only have single carbon-carbon bonds, we're going to use the AN. If we have an alkene present, we would instead use EN. If we have an alkyne present, we would use YN. And if we have both an alkene and an alkyne present, we would have to put in both. So it would be an E9, EN for the double bond and YN for the triple bond. And then, of course, out front, we're going to put any stereoisomerism that we have present. So most of the examples I'm going to give probably won't have R and S and E and Z. I'm assuming at this point that you know how to do that. But I might throw in a few examples in a later video on that. Okay, so bottom line here is you want to memorize these substituent prefixes and then also the suffixes. And so you want to try to remember which is which too. So the hardest one I think that students struggle with is the amines. So one thing to notice is that when we learned a lot of our substituent names, we had iodo, we had chloro, we had fluoro and bromo. We also have the substituent nitro, which is the NO2. So notice that all of these end in O, and so that's one of the ways I remember that when we have an amine and we use it as a substituent, that has the O ending. And then also here, when we're naming it as the functional group, we're actually literally giving it the functional group name of amine. So that's a little tip to remember that. Notice we do have a few other of our substituent prefixes that end in O. It's not all of them, obviously, but there are quite a few. And then we also have a lot of these ending in the YL ending. So those are some examples of some different substituents. Some of you may be questioning why the carboxylic acid even has a prefix, but this would be in some situations, say, where you maybe end up with two carboxylic acids in the structure, or for some reason one of them ends up being on some sort of side chain and you have to name it as a complex substituent. So there are situations where that might happen, but for the most part, for our purposes, it's going to be probably the highest ranked functional groups. The other thing I want to point out here on the ranking that might help you remember the ranking. So I think there might be songs and other things out there that people use to remember these. A lot of students will sort of like memorize this and like brain dump it on the quiz or test whenever they get it to help them, remember it. So whatever method works for you. The other thing I want to point out here about the numbering is that we're not going to do thiol or imine. So I still have them in the numbers here. And I don't care if you learn these specific numbers I have listed here, or if you, leave the thiol and the imine out, and change the numbers. The most important thing is that you know the rank order. So carboxylic acid is higher ranked than acid halide and that sort of thing. One thing I want to point out here is that the carboxylic acids, acid anhydride, esters, acid halide, amide, nitrile, and aldehyde all have to come at the end of the chain just by the nature of their functional group setup. We're always going to have that at the end of the chain. And so that's part of why these would be the higher ranked functional groups. And then once you get into ketone, of course, that's similar to aldehyde, but it's in the middle of the chain. Then we have alcohols, and we have amines. So the other thing here that might be helpful is that we also have our more oxygen related carboxylic acids, acid anhydride, etc. are higher ranked. So we have these all having oxygen present. Then we have our amide, which has a nitrogen in it. Then our nitrile. Okay, and then aldehyde and ketone are what's known as the carbonyl compounds. So those are going to go together. They're very similar in structure and in reactivity. Okay. I just want to spend a little bit of time here on the trivial names. There is some systematicness to these. So notice that whenever we have the H here, and the H here, and the H here, and the H there, these all have form in the beginning of the name. Okay, so when we see form, that basically means that we have a carbonyl with an H next door. Okay, and then acete is going to be the CH3 next door to the carbonyl. So acetic acid, acetyl bromide, ethyl acetate, acetamide, acetonitrile, and acetaldehyde. And then acetone. So the acetyl group is basically this right here. Then the next one in the next row is benzoic acid. So benzoic acid is going to be a benzene ring next door to a carbonyl or attached directly to a carbonyl. So we have benzoyl chloride. This is ethyl, and then this part is the benzoate. Benzamide, benzonitrile, benzaldehyde, and benzophenone. And then the last over here, there's not really a category for these, but acrylic. This is acrylic acid. Acetic anhydride. So again, this has that acetyl group. That's where the acetic comes from. The acid anhydride is where you're going to have, if you put water in here, basically, these are very reactive, and you would end up with two equivalents of the carboxylic acid. So you can sort of imagine the reverse reaction is we're losing a water molecule and going to the acid anhydride. Then down here, this is N,N-dimethylformamide. So we have our two methyl groups here on that carbon. It's a formic group here, or the formal group. And this is a solvent that's sometimes used, and so you might see it listed. And then here, acetophenone. We've got, again, the acete comes from the acetyl group there on that side. Okay. In the next video, I will do some examples of naming using some of these functional groups. I'll go through each functional group at a time.